Hi guys, today I will illustrate how you can use Creo parametric to carry out a finite element analysis similar to this. As you can see here, we can get displacement in terms of magnitude and also stress volumetrics. We're going to perform this analysis. We're going to start with a model creation, then we perform analysis and get result. Okay. Therefore, I'm going to start a new file in Creo parametric. I have started an assembly in Creo. I'm going to use a top-down design approach. Therefore, I'm going to start by saying create a model. This one is a file name. I'm going to use the default part names, that is a 008. I'm going to use the same default. We need 3 parts. For the placement, just say automatic, say OK. This first part, second part, same case applies. OK. Third part, create. Third part, OK. Like that. I'm going to start one by one. 8, 9, and 10. Right click on part 8 and select activate. Activate the selected model. This one is an assembly composed of 3 parts. Therefore, we're going to design in context inside the assembly of 3 parts. Therefore, I'm now in the part environment, as you can see, and we are using inches. Therefore, I'm going to go to the. I need not to activate the planes on this plane. On this plane here, let's sketch on this plane. View normal, like that. I need a center rectangle, like that. 5 inch, 5 inch versus 5 inch also. Let's use 5 inch, like that. Then another rectangle, like that. But for the construction, that is 4 inch versus 4. Then a circle on this point, like that. Undo, deselect construction mode. I need 4 circles here. That will be, these ones will be our mounting point of 0.5 an inch. Okay, we can now extrude the part by an inch or half an inch. Let's go with half an inch, like that. We can hide planes now. We can round off these corners by 0.25 an inch, like that, like that, like that. This one is our first part, is our base. This one is our base. Next, we need to go to the next part, activate. Next part, click here, sketch, view normal to you. Basically, Control D to go isometric. Then I need center rectangle here, like that. Let's view normal first, like that. Yeah. We need a 3-inch versus 3-inch. Let's go with a 3.5. 3.5. Yeah. 3.5. Yeah, that's better. Then select extrude by 0.5 an inch. Then round these corners. Let's use 0.5 an inch corners to be away from the mounting hole as much as possible. I want to give appearance to this part. Go to view, appearance. I want to use this appearance. Select body or part, this part. like that. Then lastly, activate my third part here. Click here, sketch here. I want to go to the center rectangle like that. Then I want to delete this bottom segment because I want a C channel. Let's see the front view, right view. Yeah, I want right view. This one to be, yeah. Let's first for offset. Therefore, select this. Oops, this line, this and this. Offset by 0.25 an inch. Is a loop. Okay. Let's see a chain. This, and this. Okay. 0.25. Oops, I didn't forget. I didn't select everything. This, this. Offset a chain by 0.25. Basically, you can still draw this triangle also, rectangle like that, and delete this segment. Then take a line from this point to this point, another line from this point to this point, delete this segment like that. 2.8. Let's go with the dimension. Let's go with a 2.5. What else? With a 2.4. Or let's go with a 2. I'm just guessing these values. I don't need this. Therefore, I want this to be uniform or round. Yeah, that can work also. Okay. Then extrude this. You go to model, extrude like that. Nope, oops, like that. I don't like it so much. Let's edit this and use to. Okay, yeah, that's better. Let's make it longer by, let's use 6 inches. 6, yeah. Then let's fillet this and this by 0.5. Again, this and this. Let's use 0.3. Go to the sets, set 1 also 0.3. It's just for the demonstration. Again, this and this, fine. Then I need to assign appearance. Let's see, I'm going to use this. Assign to this part. Yeah. Last three, go now back to the assembly. You can see my 3 parts. Let's go back to this, and I want to sketch here so that I can have my mounting hole at this point. This is the hole whereby we're going to apply our load. Okay, let's now remove like that. Yeah, then go back to our assembly. That's how you model the parts that you're going to use in our simulation. Next is you need to assign material of these 3 parts. For you to assign material, right click assembly, edit materials, go to legacy. You can select maybe steel here, say okay. Now the materials is steel. Um, that's how you assign material. Let's now start the actual analysis. The first step is we need to define the weld. Remember this C channel is welded to this bracket, while this one is welded to this. Therefore, we need to define weld. Therefore, you go to the application here, go to the welding, and we're going to use a fillet weld. We can either have double-sided or single-sided. Let's start with a single-sided. That applies to these two brackets. On the location, for the first set, select here, but for the second face, select this face. As you can see, a small weld appears here. Let's use a 1 inch, 2 inch. Yeah, let's use 2 inch weld. You can see the preview, but this preview is a surface. I want a solid. Yeah, if you select solid and say OK, you can see your weld is formed. This is the weld, that is a fillet weld, single-sided. Same case applies to this bracket here, C channel to this. Go to the fillet weld, but in this case we're going to use double-sided of 2 inch. Then for the locations, we need arrow side and other side. For the arrow side, select this face, but other side, rotate and select inside of this. Go to the other side. For the arrow side, this face. For the other side, same face. Options, we need a solid. As you can see now, if you zoom in here, if you say OK, my weld becomes a solid of double sided. Therefore, it is a fillet weld on double sided. You can see the symbol for the double sided is on the both side. That's what we mean by the double sided weld. Next, we need to go to the, if I go back to the application, I want to go to simulate. Okay, convert, that's fine. You're converting the units inches to the millimeters, that's fine. We need now to check our geometry. Therefore, if you check your geometry, let's see, if you go to the refine, if you review your geometry, you can see how it looks like. Let's first of all close this. Let me first of all go back to interface. I want to define these interfaces. If you go to the refine model and select interface, I want to say this. I want to say these two parts they are free. Therefore, you can see they are free type. The interface between this and this is a free. It can either be boarded, contact, or a free. For the contact, we'll do this later. Let's go with a free. It is a component to component, this to this. Okay, again, interface. These two are also free. They are just joined using a weld free. It is a component to component free. If you now go to the review geometry, you see how they are. They are free. There's nothing connecting. These three bodies are not connected. They are just joined using a fillet weld. Next, let's define this weld. If you go to the refine model weld, we have a weld here. We need now to define this weld. The first one is it is a weld feature. It can be a perimeter spot, but today it is a weld feature. And you select this weld, you can override and assign material. You can assign the material of this weld, but for now we're going to assume it is a steel. But for precise analysis, you need to define the material of this weld. Okay, again, weld, it is a weld feature here. This one here, override assign material here. The reason why I'm selecting override for you to assign material, okay. Same case applies. If I go back to now review geometry, you'll see now my geometry has this weld that is connected. You can see this small window. This pink means it is a bordered interface. You can see here, bordered interface. It means this weld is bordered to this part. If you rotate back, you will see everything is pink because it is a bordered interface. This part is bordered to this using weld, this to this using weld. Okay, let's go to. If you go to the autogen close, let's go to the autogen create. We want to auto generate the mesh. For now, we're going to use this rough mesh for purpose of analysis, but you can always refine. Close. No. Again, autogen create something I want to show. I want you to see that whenever we have the interfaces usually have a common node. You can see, if I zoom here, this node is the interface between this part and the world. Same case applies here. We should have a node. I will go into deeper details on the mesh analysis later, but for now, let's focus on just analysis. Next is I'm going to fix these four holes. Therefore, I'm going to go back to home, look for the displacement. For the displacement, differences is a surface. We can use individual, boundary, or intent. Basically, I want to select, if you select intent, if you select one face, you can see they're selecting everything. If you go to surface, let's remove all. If you go to boundary, see what happens when you select it, selects everything. If you use boundary option, but you should use individual. Therefore, for the individual, you have to select now using control. Like that. And I want to say all these surfaces are fixed. You can see this means free. For the translation, free, this free fixed, or you can also define, you can prescribe the initial motion. Therefore, I'm going to use everything is fixed on the translation. You don't need to worry on the rotation, because if anything is fixed, it can't rotate. Therefore, just fix everything X, Y, and Z like that. Then I need now to define my load. Something to note is my load will be hung onto this. We are going to have like a rope that is connecting these two holes. If my load is somewhere here, I'm going to create a point to present my load case. Basically, what I mean is, my load is somewhere here. Therefore, on the front plane, I'm going to create a point. I want to go front. This point to reference this edge and reference this edge. Basically, I'm going to assume that my load is here. The center of mass is at this point. Therefore, this point represents my center of mass. The next thing is about, I'm going now to attach mass to this point. If you go to refine model, mass, I'm going to say is a simple mass that is a I want to select this point. My mass will be attached to this point. This is the center of mass. Then the value I can use, let's use 50 kilograms. You can see now the mass here. I want this mass to be supported by these two holes. Therefore, I need now to connect this mass to these two holes. And you usually use what we call weighted link. It is like I want to connect this mass to these holes. Therefore, I'm using the independent side is a point. This point is independent. And here I can select this point, dependent here. I'm selecting this point. But here it is a surface. Independent is a surface. Sorry, independent is a surface. These surfaces. Dependent is this point. Therefore, for the dependent, I'm going to use individual and select this surface. You can see it has selected two surfaces. If you say OK, it creates 2 points this side and 2 points this side. For some reason, it just shows link on one side. It doesn't show the link on the other side. But if I go right, you can see it is connecting this to here. For some reason, it doesn't show the connection this side, but still it connects. Okay. Therefore, we are going to hang our mass onto this hole and this hole. Next, once you hang the mass, you need to define gravity. Go home, you select gravity. Gravity, for the gravity, I'm going to use component and use gravity along y, negative y. I'm going to use 2g. 2g means it is 2 times the actual gravity, and it is along negative y-axis. If you say preview, you can see your gravity here. It is pointing downward. If I was to use maybe z-axis, and I say preview, you can see it's pointing on a wrong direction. Therefore, it is a y-axis preview. Say OK. You can see your gravity there. Then it's a good idea to assign material here. Assign material. Material is steel. Fine. Lastly is now to run analysis. Let's see now how you can run analysis. You go to the analysis and studies. You go to the file. I'm creating a static analysis. I'm going to use, can give it a name, analysis 1 of welded joint, like that. You can give some description here. Make sure this constraint, load case, and the constraint for the displacement are checked. Method, we usually have three methods: single pass adaptive, multi-pass adaptive, and a quick check. I'm going to create a video to explain these three methods for the convergence in details. But for now, select single pass. Still the same case, I'm going to illustrate what we mean by advanced controls here. But for now, leave everything as a default, select OK, then run. You can say no. It's running, you can see. It has completed because it was a simple analysis. You can see completed. Then select this analysis and show results. Another window appears. Quantity, let's start with the displacement in millimeters. Magnitude, for the display, I want to say deformed. I'm going to use a scaling factor of 10. I want to show element and load, and I want to animate using maybe 8 frame or 16, depending on your machine. Okay. Let me deactivate elements and also don't show the load. You can see how it is behaving. displacement, and as you can see, this purple means it's a 0. You can go to view. If you go to format edit, I like using glare for 0 here. For 0, I like using this. See, okay. Let me edit again. Same case here. Okay. Yeah, I like this format. As you can see, the displacement maximum is 0.03 mm. That's how you show the displacement. Okay, if you go home, you can copy this window. Just select copy. Instead of showing displacement, let's see the stress in MPa, and let's see the von Mises stresses and display. You can animate or not. Then say okay. You can see stresses on this joint, how they are. It shows you the stresses. Maybe if you want maybe the stresses to be distributed over, let me first for the check deformed. You can see this means it is showing deformed and undeformed at the same time. If you select continuous tone, you can see now the stresses are also being distributed to other sections because you have selected continuous tone. Let's use scaling. Let's scale by 20% and see what happens. Yeah, we're just trying to scale to see the von Mises stresses. That's how you can carry out a quick finite element analysis using Creo parametric. And you can also view all these quantities. If you want to see the strain energy per unit volume, you can see. If you want to see P level is a type of criteria that indicates whether the convergence has been reached. If you select P level and show, you see, we are at P level. At these ones, we are at about P8, P6. It means we have converged well. Let's go back to stress and MPa, but Mises show. Okay, that's how you can carry out a simple FEA in Creo parametric. My future videos, I'll go into deeper details, maybe using bolted joints, more joints. Stay tuned for more videos and thank you.